Hello everyone, good morning. Today I am presenting on hierarchical clustering, a fundamental clustering technique in machine learning and data analysis. We'll go over how it works, its types, advantages, limitations, and where it applies. Introduction to hierarchical clustering. Hierarchical clustering groups data into a hierarchy like a tree. This method doesn't just tell you how data should be clustered, it shows how choosing different data points related to each other. It can be done in two main ways: aggl- agglomerative, which is bottom up, and divisive, which is top down clustering. Agglomerative versus divisive clustering. Agglomerative In agglomerative, we start with every point as its own cluster and gradually merge the closest pair. In contrast, divisive clustering starts with all data in one cluster and splits it step by step. Agglomerative is more commonly used in practice. How hierarchical clustering works. The process starts by computing a distance matrix. For example, using Euclidean distance. Based on this, we merge or split clusters using linkage criteria. First, single linkage, which is shortest distance, complete linkage, which is longest distance, average linkage, average distance. This process builds a dendrogram, which is a tree diagram showing cluster relationships. Advantages of clustering, hierarchical clustering. One big benefit is that you don't have to choose the number of clusters in advance. It gives you a dendrogram so you can visually explore the cluster structure. It's also capable of finding nested clusters, making it useful for revealing complex relationships in data. Disadvantages of hierarchical clustering. However, it's not perfect. It's computationally heavy for large datasets. It's also sensitive to noise and outliers, and once it merges or splits clusters, it can't reverse that decision. Also, it might from unbalanced clusters depending on the linkage used, and it is also expensive. Next, applications of hierarchical clustering. Hierarchical clustering is widely used in biology for building phylogenetic trees, in marketing for customer segmentation, for document and text clustering, in image processing for segmentation, in social network to analyze communities. Comparison with other clustering methods. First one is k-means. Compared to k-means, hierarchical clustering doesn't need the number of clusters beforehand but is slower. Compared to dbscan, it doesn't handle noise as well or detect arbitrary shapes as effectively. The method you choose depends on your data and goals. Conclusion. To conclude, hierarchical clustering is a powerful tool when you want to explore the structure and relationships in data, especially when the number of clusters is not known in advance. But for large or noisy datasets, other methods like k-means or db-scan might be better. Thank you for listening.